I joined the school in early 2004, and it was my first full-time lectureship job. And I was kind of directed towards Southampton because I thought it provided a good research environment and a good teaching environment. There seemed to be a good system of support for both research and teaching, and I think that really helps both students and staff. My research is looking at visual perception kind of generally. And so the problem with visual perception is you have a two-dimensional retina, you have a couple of those, and there's a lot of information that hits the back of your eye, hits those 2D retinas. The device that we're looking at here is a visual haptic setup. So this device allows us to present both the vision information through the monitor and the mirror there, and touch information. So the senses seem to combine to help you figure out what's out there in the real world, and we can use this device to present vision information and touch information independently and see how people combine across the two different cues. There are other kind of clear practical implications. So there's more and more emphasis on virtual worlds in terms of training people in various disciplines to be pilots or doctors or along these lines. And if we have a better understanding what the sort of visual information is that people use to perform tasks, then we can create more realistic environments for these people to be trained in. I think the thing that I enjoy on a day-to-day basis is just the problem-solving aspect. So being a research scientist, there are problems in designing experiments and setting up experiments and conducting research and evaluating the data. That's the bit that I come to work and really get fired up about.
I started my PhD up at Durham University because they had a course there on developmental psychology, a master's degree that I was sort of taking part in. And then in the final year of my PhD, my supervisor moved down to Southampton to become a professor in experimental psychology here. And so I moved with him to finish my PhD research. And since coming here, we've set up some eye movement labs that are, I think, among the best in the world. So they're absolutely amazing resources to have access to on a day-to-day basis. They're certainly some of the best in the UK for sort of the range of equipment that we have and the range of experiments that we can run with that combination of hardware and software. So my line of research that I'm interested in is children's eye movements in reading. And the reason I do this is because when you measure their eye movements, it gives us incredibly accurate, with sort of temporal and spatial accuracy, a record of how their brain is processing the language, because we can look at things like which words they look at, which words they don't look at, the order that they look at the words in, whether they look at some of them twice, how long they look at the words for. All these kinds of things can give us a really good idea of how their brain is processing the language as they're reading. The best part for me personally is definitely working with children when they come in, because they're just so enthusiastic about taking part in the research. Whenever they get to the end of an experiment, we always explain what it was all about and why they've done it. And the kind of questions that they ask always amaze me for the level of understanding and how keen and interested they are to know what they've done.
I'm interested in studying close relationships, and I do this from an attachment theory perspective. In other words, I think about how the quality of people's relationships while they're growing up, for example, with their parents, influences how secure or insecure they feel in their adult relationships, in particular their adult romantic relationships. And so what I like to do is bring people into the lab and ask them questions about their relationship quality and their thoughts and their feelings about their partner and their relationships. And I can do this by giving them questionnaires, for example, but I also can have them come into the lab and interact with each other. For example, I might have them talk about a problem in their relationship and observe their conflict resolution styles or how they deal with conflict. Or I can also have them come into the lab and talk about one person's problem and have the other person be a support giver. So look at caregiving, support seeking, and the extent to which a person can help their partner with a problem.
I first joined the university in 2002, and that was when I came here to do my undergraduate degree. So I spent 3 years doing my undergraduate degree, and I enjoyed that so much that I stayed on and did a master's, and now I'm in the second year of my PhD. Some research that I've started to get involved with recently uses our lightweight, perambulatory, head-mounted eye trackers. That means they're eye trackers that allow us to record eye movements people make, but rather than having to do it in a laboratory and sit still at a desk and keep their head in one place, we can put the head-mounted eye tracker on people, and get them to walk around and do realistic tasks. For example, get them to drive a car. Rather than driving a simulator where they'd have to stay still and it wouldn't be very realistic, they can go and actually drive a real car, and we can measure their eye movements while they do that. Another example is we can get them to play sport, and whereas you could get some kind of simulator in the lab, getting someone to actually play cricket or football with the eye tracker on allows us to get a really realistic pattern of eye movements and see what people really do in those scenarios.
So this is the head-mounted eye tracking equipment, and as you can see there's a backpack that allows the wearer to walk around and perform any kind of tasks that we need them to do. They haven't got to be stuck in the laboratory, they can go out into the real world, and all the equipment goes into this backpack. It's very, very lightweight. We have a little box here with a microphone attached, so if you want to record speech, for example during an interaction with another person, we can record what people are saying. The headgear that we get the participant to wear, and as you can see it's like a glasses frame, and there are two cameras on the glasses frame. There's one here which points outwards to wherever the person is looking, so if they move their head in any direction you get to see exactly what they're looking at. The second camera is this one right here, and that one points towards the eye, so whenever the eye moves in any direction, this records exactly where the eye is pointing. And by putting these two streams of information together, we can see in the environment, wherever the head was pointing towards, exactly where the eye was looking at that particular moment.
Another way that eye movements can be used in real world situations is by looking at people performing everyday tasks, such as making a cup of tea. So if we put the head-mounted eye tracker on someone and ask them to go into the kitchen and make a cup of tea, we can see what they do with their eyes and how that relates to what they do with their hands and their body. And tasks such as this, when they use eye trackers, are often used in hospitals with patients who have suffered brain damage. And this kind of everyday task is used to make sure that patients are functioning at a level that enables them to live independently. So if someone's recovering from an operation, one of the ways they'll make sure that the people are ready to go home or to go and live by themselves is to get them to perform this kind of mundane task, to check that all the bits of the task are working properly, to check that the person's brain is working in the right kind of way. And eye movements helped us to understand what's going on in the brain when this kind of task is performed.
After I completed my undergraduate degree at the University of Leicester, I came to the University of Southampton to study for a PhD in the Institute of Sound and Vibration Research. And after that I decided that I wanted to pursue a career in psychology. So I came to the School of Psychology and started work as a research fellow, working on a project called Life Guide. My research is looking at behavioural interventions, which are packages of advice and support designed to change a person's behaviour. Traditionally, behavioural interventions have been delivered face-to-face, but this isn't cost-effective and the advice cannot be delivered to individuals 24 hours a day. The internet is a better means of delivering information and advice because it's cost effective and can reach larger populations 24 hours a day. Life Guide is a software package which enables researchers and health professionals to create internet-based behavioural interventions without having any knowledge of programming. To investigate the utility of Life Guide, an intervention called the Internet Doctor was developed. The Internet Doctor promotes the self-care of cold and flu symptoms. It asks you diagnostic questions on your symptoms, and then it gives you advice on whether or not you need to see a doctor, and also gives you advice on what you can do to help yourself feel better. The aim of the Internet Doctor is to promote the self-care of cold and flu symptoms and reduce unnecessary visits to the GP.
Electrophysiological research involves recording EEG, or the electrical activity of the brain. And it involves placing an elastic cap which contains 68 small disc electrodes on the participant's head. And this cap is used to measure the spontaneous electrical activity of the brain and also the brain's reaction to simple stimuli. An example of some of the research we do here would be to record EEG in two conditions. The first being a resting state condition, which we just ask our participants to sit within the testing room in a comfortable chair and simply just to relax. And in the second condition, we ask them to participate in a choice reaction time task, so we just ask them to respond to very simple stimuli by using a button box. With regards to electrophysiological activity, we're particularly interested in some very low frequency oscillations, which are thought to be associated with a network of brain regions observed to be particularly active during rest. With regards to goal-directed activity, it's observed that this network of brain regions is in fact attenuated or significantly reduced. This hypothesis proposes that low frequency activity in the default mode network will in some circumstances impair task performance. So one of our aims is to investigate the hypothesized dysfunctional transition from the resting state to goal-directed activity that may be present in some disorders such as children with attention deficit and hyperactivity disorder. Our research within the Institute aims to inform contemporary models of ADHD and also to inform diagnostic models and ultimately to translate our research into clinical practice to the benefit of children and their families.